16. No. Oh, good Lord Almighty. We're gonna be here for a while, boys. Oh, good Lord Almighty. Oh no. This thing is not gonna stop until it you know how long we're gonna be here for? Alright. Okay. So allow me to start this off with explaining a few important concepts that you may need to understand. First of all, variables. So when you create a variable as a programmer, it stores it in a thing called a RAM. RAM is called random access memory. And basically, this is where a lot of things like variables are stored into the computer. When you have a variable and a programmer makes it an integer variable and he names it Jeff, he can make this variable equal to anything. If he makes it equal to 12, basically somewhere in RAM, the computer decides to store it somewhere. So say an address, in RAM address 45, the computer decides to store this variable inside the RAM slot. This memory address is now going to have the value of 12 in binary. Simple as that. Now, one thing you may need to understand is that to a programmer, we can name whatever we want. We can name any variable whatever we want. For instance, if I name it Jeff again, there we go. This variable name is Jeff. To me as a programmer, it is named Jeff. But to the computer, it is actually completely different. Think of it like this. To me, Jeff is a person. He has a name and he has a purpose, holding the value 12. However, to a computer, though he does have a purpose, he is just in a line. These are a bunch of different people. They all have different kinds of names, whatever their names are. But to a computer, Jeff is just a number in a line of a bunch of people. It doesn't matter what you've named it. To the computer, all Jeff is just a number in memory. If he is in storage, like a address 495, to the computer, he is just 495 because he's located in memory address 495, and that's all Jeff is. But to the computer, but to us, his name is Jeff. A very important concept to understand. Next thing you may need to understand is the concept of methods. Basically, in a method, you can do whatever you want. If you call this method, it basically executes a bunch of code by just calling it. However, one thing you may need to understand is passing things through a method. Basically, what happens when you pass things through a method is, first of all, you'll see method name, like method. For passing something in, you'll be seeing stuff in parentheses, like something like int j. Basically, when you call a method, you want to put whatever is asked here inside the method. So if a method is asking for integer j, you can put whatever variable you want into parentheses and it will use that as an integer, right? Now, if you need a better idea of what that means, let's say this is CPU. CPU needs someone right now to do something for it. It just needs anyone. Now this person right here, named M1, is offering to just do whatever. It doesn't matter what it is, he will just do it. Basically, CPU goes to M1 and tells him to do something. So he does it, and there we go, it's done. Now, here's M1. Now here is M2. The difference between M1 and M2 is saying he will take papers and edit them. The papers right here. Thing is, he needs a paper. If you tell him to edit something and you don't give him a paper, he won't do anything. If you don't give him this paper, he'll say, no, I'm not doing anything. Now this is where the difference comes in. If the CPU doesn't need M2 to do anything, he can just go to M1 and say, hey, do something, and M1 will do it. However, if CPU needs M2 to edit this paper, CPU will go to M2 and say, hey, here is my paper right here. Edit it out. And basically what M2 will do is take that paper and do what he's instructed to do. He'll edit it out, do whatever it takes, do all that, and then he'll return it. Or just do nothing. Whatever it is, he'll use whatever you give it to him, and he will do whatever you tell him to do. Say if he says, hey, take this $, right here, and give it to the bank. Now say if you tell him, give this $, to M2 and put it in the bank. If you demand M2 to put it in the bank, M2 will have no idea what you're telling him to do because he just wants to edit papers. So if you try and make him put something in the bank and all he wants to do is get papers from you, well, guess what? He'll also say no. However, if M2 is wanting to be responsible to deposit your money in the bank, if you go to him and say, hey, deposit this $, into the bank, he will take that $, and do what you tell him to do. That is basically a real-life representation of method passing something through a method. So those are two important concepts you may need to understand. So let's get into the code here. So right here, there are some basic includes. So let me quickly just change this to, there we go. Yeah, there we go. Okay. So first of all, there are some basic includes. Let's make sure everything's fine. Can you see my mouse? Apparently not. Whatever. This right here is all just including stuff from libraries like IOStream, CMath. You don't have to worry about this. However, this right here is a method. This is the first instance of a method. You can see the type of thing it returns. This right here represents what it needs to return. For instance, it needs to return an integer value. GetHand is the method name. And then inside these curly brackets is the method body, which is responsible for doing whatever it does. Right now what this is doing is it's seeding the random number generator. And what this is just getting the time. And then it returns a random number. Right now, nothing will be done when it reaches this point. When the code is reading through all this, nothing will happen here. The only time this method will do anything is if it's told to do something. Keep that in mind. Next is struct. Structure is a special little syntax that allows you to make like a object here and allow you to assign it a bunch of different variables. Right now, these variables are not actually stored in memory. They are initialized, but they do not actually have anything stored in RAM. However, the magical thing about making a structure is that you can create variables that use, well, these values. So for instance, if I were to make game status, which is the name of this, because structure is basically handled as a class. And what happens is I make a game status named, let's name it Jeff, once again. Now, you see here, Jeff right here. So let me make another one, make Jeffy is equal to 0. If I try and do Jeffy dot, you see nothing is happening. That's because Jeffy is just an integer value. It is just a variable stored inside RAM. However, game status Jeff, however, now has access to 4 separate variables. And you see here, if I were to change this variable right now to be equal to 3, and go to CPU and change the hand value to be equal to 5, they will have 2 separate values in 2 separate variables. They will have the same name variable, but they will have 2 separate locations in the memory address. Alright? Think of it like this. Say, for instance, you have a person named Max and another person named Max. They are not the same person. Max goes into class C3. However, this Max right here goes into class Z7. They go to separate, completely different classes, and they are completely different people. However, they have the same exact name. Just because they have the same exact name does not mean they are the same people. That's basically what it is. And now just think Max as a variable and think of the classes as memory addresses. So yeah, that's a bit of a idea of what advantages structures have. This is what a structure basically is. So long CPU, but these three right here is basically just telling the program that there will be the methods named this. Don't worry about this part, it doesn't really matter, and it'd be too complicated. Alright, int main. This is basically the main method. This is what is executed at the very start. When you run your program, everything in the main method is started first. So basically, game status user, game status CPU. All I'm doing here is just initializing the fact that how these two things are game status objects. String val. Strings basically hold like lines of text. Basically, it's a lot more easier to explain in Java because in C++ there's a bunch of different kinds of strings. But just think strings as being like a string of text. That's all you have to really think of it as. Alright, std if stream. By the way, this means standard library, get your mind out of the gutter. Anyways, this is if stream. Basically what this is fstream. When you include fstream is just file readers and writers. Say for instance you have a text file right here. Basically what fstream does is it can either read or write inside this file. In this instance, you have this stuff right here. So if you have std ifstream reader, ifstream is basically the data reader of a file, and it will read this file. Now the way you have to read this file is a little quirky. You have to read it through a while loop, which can be a little difficult because it basically has to loop through all of the data that's located inside this file. So you go reader is going to val. Basically this feeds into value right here. And first of all I should say the while loop basically loops through the file until it reaches the end of it. So basically it reads this, reads this, reads this, and then reads this, and then it says, oh, I'm at the end of the file, so it stops. And that's basically what it's doing here. So basically every time it loops through, whatever is on the current line it is reading, say for instance it is currently on line 2, it will bring 2 and store it into val as a string. Alright, then it will increment this integer by 1, because plus basically means increment by 1, and then we reach this complicated little thing. This is a Boolean operator, I think it's called, I'm pretty sure, and it's a little complicated. At first I didn't even think this might not even worked, but it did work. So let me kind of read to you what this means, because at first it seems really overwhelming. Here's what it means. If the variable inc is less than 3, and this checks if it is, if inc is less than 3, do whatever's inside this parenthesis. Alright? If this is true, do all this. If it is not less than 3, do all this. Alright, that's what it is. And it is separated by a colon. This is the true statement. This is the false statement. If it is true, it will do this. If it is false, it will do this. Alright, make sense? Okay, if it is true, it will go inside these parentheses right here. However, inside these parentheses, there is another Boolean operator. In this situation, it is testing to see if inc is exactly equal to 1. If it is, it will execute this code. Alright? If it is not true, it will execute this code. The reason why I do this like this is because since this is inside a while loop, I need to make the program know what value is needed to be altered. Because basically what this is line 1 is the user's money amount. Line 2 is the user's win streak. Line 3 is the CPU's money amount. And line 4 is the CPU's win streak. I need the program to know what value is being altered. Alright? So for the first thing, user.money is equal to this. Basically, it's setting up the value. you may realize user.money, the first line is the user's money amount. And if it is not true, it goes to line 2, user.streak. Remember, the second line is the user's win streak. However, if it is not less than 3, it'll go over to this line of code over here. If it is equal to 3, it will alter CPU.money. And again, this is the money line. And if it is not true and is not equal to exactly 3, execute this code, meaning it will be altering this one. Hopefully that makes sense. I can't explain it any better. Hopefully that makes sense. So basically it's just testing how far along the while loop it is. And then when it finishes this while loop and it reaches the end of the file, it closes the file. Alright, next. We move forward. Car, play game. Car, hit. What a car is, or a char, whatever you say, I say car. Car is responsible for, like, holding, like, characters. Like, car is short for characters. And in code, basically a character is responsible for holding one little value. For instance, if you have the letter C and it's capital, C is represented by a binary value, like say this, which is probably not true, but just pretend that is true. C, capital C, is represented by this binary value right here. Lowercase c, however, is represented by an entirely different binary value. What car is it is responsible for holding, well, for basically saying, hey, this variable right here, car Zeke is equal to y. But this is telling the computer is the variable Zeke has the value of the binary for y. Alright? And that's kind of what it is. So hopefully that makes sense. That's about as far as I can get there. So yeah, car, play game. There you go, car, hit. So basically, alright, right here, over. You will see this later. Keep in mind, over. Because this is called a label. And I don't know if this is something that can be done in any other language. But so far, I've only seen this in C++. But this is a label, and I'll explain that later. Just keep that in mind, that this exists right here. Anyway, so while play game is equal to y, this is called a game loop. And basically this loops through the game until the game is finished, or until you try and exit out of the game. Right now is equal to y, so when it reaches this while loop, it checks to see if play game is equal to y, which it is. So it will do this. And we'll continue doing this over and over again until this right here is not met. If this little test is not met and it is not true, this while loop will no longer execute. Alright, good. Okay, so cout is basically printing stuff into the console, the command prompt. That's all you have to worry about there. std2 string basically converts whatever is put inside the parentheses into a string. This is all stuff that is pretty simplistic. It's just putting stuff into the console. You don't have to worry about it. cin, however, allows you to input things, and it stops this entire process long enough for the user to put something in. So std cin, this little thing right here, user.bet. Whatever you type and press enter to will be stored inside this variable. Alright? Okay, so to explain what's going on in the full picture, right now you just started the game. All of this just happened, you do not see anything yet. But right now you start seeing stuff showing up on screen. So one thing that happens is that it reads out all this and then it prompts you to put something in. This is basically telling you, place your bet on this round. You place your bet and then it does this. Basically whatever you bet, it removes that amount for your money count. Which makes sense, right? If you bet $500, you just put down $500, meaning you lose $500 from your total money amount. That is what is happening here. So basically it just removes it from your money amount, and there you go. Okay. So moving down, this basically tells you what the CPU currently has. And then what happens is CPU.bet is equal to CPU bet CPU. Right here is a method call. Remember when I talked about methods? Right here, this is a method call. And basically, CPU bet is a person. And right now, CPU bet is asking for something to be given to him before he does anything. So right now, let me go over to CPU bet. This is the CPU bet method, and it is responsible for returning a long, which a long value is integer is 32-bit, long is 64-bit. That's just that. Anyway, what CPU bet is asking for is it is asking for a game status object. Alright? Whatever's passed into it, it will use it as long as it is a game status object. So right now, the person known as CPU bet is asking for an object called game status. Alright? Status, there we go. It is asking for this golden thing right here. It wants this. If you try and give it an integer, it will not accept it. Alright? However, if CPU comes up and says, here you go, here I have a game status object that is named jock. Alright? It doesn't matter what it is named or what it contains, as long as you're giving CPU bet game status, it will work with game status. Alright? Hopefully that makes sense. So, let's see all that. So yeah, this is where it gets CPS. Alright, so here you go. Now remember, the magical thing about game status is that it can have more than just one integer, or more one value, one variable. So basically, since I've passed in game status, I have basically passed in 4 separate variables to be used. So switch, CPU streak, this is a switch statement, and it basically checks whatever this is equal to. Say for instance CPU streak is equal to 4, it will go to case 4. However, case 4 doesn't do anything, so it feeds into 5, which goes to here, which returns integer CPU money times 0.25. This is returning how much the CPU will bet. And this is based on how many streaks, how many wins in a row the CPU has gotten. So for instance, if the CPU has won 1 or 2 times in a row, it will put down 10% of what it has. If it doesn't do that, it will put down 5% of what it has in a default. If it has won more than 2 times, it will put down 25% of what it has. And if it has won 6 times, it'll put down half of what it has. If it has not met any of these qualifications, it will go to default and it will automatically put 5% what it has. Alright? So that's what this method basically does. It returns whatever value is put in right here. So with that being said, okay, where are we? Alright, so we got that here. So that is executed. Then we go to CPU money. It again is removed a bet. This is just doing the exact same thing that this did. It's just removing the bet amount that it bet for, and there you go. And then this is just telling me what it bet. That's all it is. CPU's bet this amount. There you go. All good. Everything's fine. Everything's fun. Everything's happy. Alright, so this is a new while loop. Now remember, hit is a variable and it's a char variable, meaning whatever is stored is like a character. So right now it is currently true. While hit is equal to y. What happens is user hand plus equals get hand. Right now user hand is equal to 0, meaning whatever you have right now is 0 and you're about to get a random hand. Now remember, get hand is all the way up here, and since I called a method, it executes that method. Now remember, get hand isn't asking for anything. It doesn't care about what you give it. In fact, if you try and give it anything, it will deny it. All you need to do is look at get hand, and it says, okay, what I'm going to do for you is I'm going to seed my random number generator, and then I'm going to give you a random number from 1 to 10. Alright? This is 1 plus rand, which is a predefined method that is already made when you import CSTLib, I think. Modulus 10. And that's what it is. That's all it is. So basically when you call this method, it will return an integer. And this is what it's going to return, 1 through 10. So when you go down here, you get your value. If you get 10, your current hand amount is now 10. There you go. So then it checks this. If user hand is greater than or equal to 21, user hand is equal to 0 to reset it, and then it says you went over 21, CPU wins. Alright, win award is another method. Now you may be a little confused here. Win award is asking for quite a lot here, but I will cover win award later because it is pretty complicated when I get to that. Just know a method has been called here. Then you go to user streak, it resets it. Okay, go to over. Remember when I said over was a label? What go to does, whenever you do go to over, it basically, well, what you expect goes to here. So for instance, the label is located right here. So when I put in go to over, it goes up and goes back here. All right, it just basically once this code is executed, it just literally goes back up and re-executes all of this. That's literally all it does. It just goes back up and re-executes whatever is below it. Pretty cool, right? Like a placeholder, and whenever you say, hey, I want to go back to this place, it's kind of like a restore point. You just go back there. There you go. All good. All happy. Everyone's happy. Everything's grand. We're all having a grand time. Now, this is if you reach or go over 21, because that's the whole thing of blackjack. If you go to 21 or go over it, there you go. Now, if you do not do that, it goes to here. This is an if statement. It checks to see if this is true, which this is not true. So this is not executed. So it skips over this. It goes here. Your current hand is, it tells you your hand, and hit. When you're playing blackjack, you tell the person to hit you when you want another card. Hit me. And no, it doesn't mean hit you and knock you down. It means give me another card. Whenever that is prompted, it prints out this into the console. If you want it to hit you again, press Y and press enter. The yes and capital N means no. If you put in Y, this while loop re-executes, meaning if you put in Y, it redoes all this, meaning it adds you another card. And if you go over 21, boom, there you go. However, if you put in N, the while loop is not true, meaning it does not re-loop, meaning it goes forward. CPU AI. Now this, you're probably like, whoa, the loss of being passed in here. Don't worry about that, alright? I also just realized, some of the stuff I've been talking about, you haven't been able to see. I've shown you stuff in paint.net, and I forgot you can't see it. So, whatever, that's fine. Hopefully you still understood. So again, hit is equal to Y. This is done, so whenever you reach this while loop again, it doesn't bug out. CPU AI does its thing. And no matter what happens when CPU AI does its thing, either the CPU AI is going to win or lose. So don't worry about it. Again, I'll cover that later. When CPU AI's method is over, the game is over. So hit is equal to Y, and then asks you, do you want to keep playing? Yes or no. And if you put in Y, that means this while loop remains true. However, if you put in N, this while loop does not become true, meaning the game is completely over. And basically what this does right here is it writes all the information, like how much money you have left, what your current win streak is, same with the CPU. It writes all that into this file. Alright, and then it closes it, and then the program's over. That's the whole thing. How long have I been recording for? 30 minutes. Wow. Okay. Now, let me explain to you a complicated concept called pointers. Because let me explain to you a new concept about methods. Alright, so you see the whole thing now, make sure. Alright, this is paint.net. So, methods. When you pass in something, say for instance, we have a guy named Method right here. This guy is named Method. Odd name, don't worry about it. Right now, he is telling everyone, hey, if you have a paper you want me to edit, I will edit it. Just give me the paper and I'll edit it. Alright, so say a person named CPU comes in with a piece of paper. Right here, this is his little piece of paper right here. It has a bunch of stuff. Method wants this piece of paper before he does anything. So basically what CPU does is he gives Method this piece of paper. However, instead of Method using this piece of paper to edit it, what he does is he creates a copy of this paper. So he goes to a printer right here. This is a printer. And basically what he does is he brings this piece of paper, he creates a copy of this paper right here. So let me select it. I'm going to copy it, paste it. This is a new copy of the paper. These are two separate papers, and what method does is he edits this paper. So he makes all the edits, blah blah blah. This paper right here remains unchanged. CPU still has this paper. However, method just made a copy. Now the thing is, since method made a copy of it, no one can use it. Only method can use this copy right now. Whenever you pass something in through a method, what the computer does is it creates a copy of it and stores it in a new memory address. Alright? It's the same exact value, it's just stored in a new memory address. So basically, it just made a copy that only this method can use. Usually, this is fine. Usually, just creating a copy is a-okay. However, in this instance, making a copy is bad because the CPU wants to use this edited paper. Right now, this paper has a bunch of edits, but it can't use this paper. Only method can use this paper. However, what a pointer does is it allows the method. It basically, CPU goes to the method, and the method says, hey, I will take your paper and edit that paper. Alright? So this is the paper. Basically, CPU gives this paper to method. Alright? And then method edits that exact paper. Does that, creates that, blah, 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 put a G there. There you go. Method's done with his job. The method is over. He gives the paper back to CPU. And there you go. The changes on the paper is permanent. If anyone uses this piece of paper, they will see these changes. Alright? That's what a pointer does. So why did I just explain this concept to you? Well, let me show you why. Basically what happened here is I had to use pointers. You see this ampersand? This little symbol right here is called an ampersand. It's usually called an and sign, but it's an ampersand. What ampersand does in C++ is it tells you that in this method, I want the memory address of this variable. Alright? It doesn't matter what the variable name is. It doesn't matter how big or how much data is inside that variable. It does not matter. It wants the memory address. Because you see, when you ask for the memory address of a variable, instead of creating an entirely separate memory address, it uses whatever's inside that memory address and edits it there. So let me just redo the whole thing here. So for a more technical example, here is your RAM. Alright, here is memory address. Let's give it O7F3F3 for some strange reason, I don't know. This isn't a memory address right here. Alright? This is a location in RAM. Now, this RAM address has a value of 23. When you pass something through a method, it basically creates a copy of this value and stores it in another random spot. So whatever this value is, it is stored in a new memory address, and let's say this memory address is allocated in memory address F6FFC or something, alright? Whatever is stored here, this memory address is now also equal to 23. Whenever the method makes a change to this memory address right here, and say it changes it to be a value of 7, this right here remains the same. Nothing is changed right here. This is changed, this isn't. However, when you have a method accept a memory address of a variable, whenever that method receives this variable, whatever edit it makes a change to that exact memory address right here. Alright? So say a method asks for an integer named whatever, it doesn't matter. Basically, instead of making a copy of whatever's passed in that has that value, it instead gets the memory address of that. So whatever change it does to this integer variable, it will happen here. it will change it to 7. There you go. It's permanent. It's used. It's changed. So instead of changing a copy that is, like I said, instead of just editing a paper that is a copy of the original paper, now the method changes the actual paper. So the CPU actually has a paper that is edited, and everyone can see that it's edited, alright? So yeah, that is what a pointer does. Well, pointers can do many, many more things, and pointers are very complicated. But that is kind of like one thing that a pointer can do. It is basically responsible for pointing into a spot or memory location in RAM. That is what a pointer does. It points to a memory address in memory. So, there you go. Right here, streak plus plus. You see right here, win award? Let me go back to that win award. The first thing that is passed in is CPU.streak. You see here, CPU.streak is a variable, right? It passes it in. Now you see here, I just passed in CPU.streak. It doesn't matter how I pass it in, I just passed it in. However, this method is asking for the memory address of whatever variable you pass in. Whatever this is, it can be named whatever, it doesn't matter. But right now it's asking for the memory address. So when it passes in that CPU streak, when it does streak plus plus, it actually increments that value in that specific memory address by 1. So say if it's 23, it changes it to 24. Now it's permanent. Now it's changed for the entire program in that RAM, in that memory address, alright? So int origin is equal to money. All these variables are just memory addresses now. That's all that's important. So let me explain to you what a win award does. Whenever you win, whoever won, their streak count goes up because they won, right? They have a winning streak. This right here stores their original money amount, alright? Now, when they have their money amount, they need to get the amount they bet back, right? They bet like $500, they just won, so they need to get that $500 back. So this gives them back that amount. However, this for loop right here is responsible for giving them their spoils, their winnings, because whenever you bet something, you usually get a percentage of it back. Like they get back all of it back plus a percentage. A for loop basically says, create an integer that is equal to 0, make this for loop constantly execute as long as this integer is less than the value of streak. And every time it loops, increment it by 1. Alright? That's what a for loop does. Is it increments it by 1 until this right here is not met. So if, say for instance, you have won 5 times in a row, this for loop will execute 5 times. Meaning your money amount will be added onto by your bet amount times 10%. So basically 10% of whatever you bet will be added into your total money count. However, if you've won 5 times, you'll have this happen 5 times. Alright? So once this is finished, you go to here, player 1 $. Money minus origin. This is what the original variable did. Basically, you store what your original money amount was into origin. Basically right here, you have your current new money amount minus origin. What this does is it takes your original money amount and subtracts it by what you originally had. And whatever's left over is the amount that you have won. So yeah, there you go. Bet in hand is equal to 0. That's just standard procedure. Okay, CPU AI. This is the last thing. The very last thing I have to explain. This, again, is taking a bunch of memory addresses. All of these are asking for the memory address, alright? So while true, this is just basically saying this will just constantly execute. It doesn't matter, just execute it. It doesn't have any things it tests. It's just whenever you see a programmer do while true, it's programmer's way of making a while loop execute infinitely until something happens. So yeah. Alright, hand C plus equals get hand. Alright. Remember when at the start of this program, when you were hitting yourself, you would get a new hand, new card every time, it would add to your total value. This is basically what CPU AI is doing. All right. And then CPU hand is this. Okay, this right here, SCD, this thread, sleep for, SCD chrono, milliseconds 500. I purposely make the thread sleep for 500 milliseconds so you can actually keep track of what the CPU is doing, just to make it easier to understand. All right, this is a test right here. If hand C, which is CPU's hand, is greater than the user's hand, and the CPU's hand is less than 21, that means the CPU has won. And remember, it does that and then win award. And then break. Basically what break does is it breaks out of this while loop and finishes it. Alright? Okay. And then if this is not met, it does else if. Else if in, I think for instance, like for Python, it's elif. Like I think for Python, it's like elif. And some other languages, it can be something completely different, like else, or if else, or something, whatever. Basically, this is just else if, right? Okay. So if this right here is not met, it will also test for this. If hand C is greater than or equal to 21, CPU went over 21, user wins. So win award goes this to user, and then break. And that's the program. Yep, simple as that. That's literally it. That is the explanation of this. Hopefully you've learned something. Hopefully you understood what that meant. Thanks for watching. Bye.